Okay, just want to clarify real quick where you should be looking this week for our work. Over here on your class pages tab, you'll see this marking period 3 benchmark review. So we'll be working on that worksheet each day. I think we'll probably do a page per day. So if you look, when you click on that, all that I've pushed out so far is the day 1. The video link will be posted here. Obviously, I'm making the video now, so I haven't posted the link. And then right here is where you'll click to complete the activity. If you want to see a copy of the review, what it looks like, you have the Word document right here. And then I think these are solutions here, worked out solutions. So if you get stuck, if you're working on this, so however you prefer to work through that. If the videos are helpful, I'll post the video link here. You can watch that. For a hard copy of it, if you like to have the paper or pencil copy of it to work on, you can print that here. And then, of course, to get credit for it, make sure you submit your answers on this link. All right. So let's take a look at what day 1 looks like. So the first page, we're going back to chapter 6. If you remember, we started off with quadrilaterals in chapter 6. And one of the things we talked about there was finding what the sum of all the interior angles were. Right? And if you remember, it always comes down to a triangle. The triangle adds up to 180 degrees, and every time I add a side, I'm adding a triangle. So once I have 4 sides, if I draw a diagonal across this way, you'll notice I have 2 triangles. Or if I come this way, I have 2 triangles. So if I had 2 triangles, that would be 360. So it always ends up being that formula n minus 2 times 180. Right, so it's number of sides, n minus 2. So we calculate that n minus 2, and we multiply by 180. Okay, so for a quadrilateral, I feel like most of you know right away when you see there's 4 that it's 360. Most of you kind of memorize that like you memorize a triangle. Triangle is 180. Quadrilateral, anything with 4 sides, since we looked at so many of them with a rhombus and rectangle and square, that they add up to 360. So to solve for x here, okay, I have to add up all 4 of these angles, right? So I'm going to add up the x portions first. What do I have in terms of the x's? Okay, I have 2x, 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 and 3x. So that's going to be 9x. Okay, and then what do I have number-wise? I have plus 20, but then I also have minus 10, minus 10. Okay, so I'm going to have 9x basically plus 0. This is a 0 sum. That's equals 360. And then that's how we solve for x. So I would divide both sides by 9. Right? And I think we get x equals 40 for the first one. Okay, some of the interior. So we'll watch these next two. One is asking for interior, one's asking for exterior. Okay, so one of these we have to use our formula, and the other one is just a super easy rule. So the sum, and again, this is the sum, so I don't want just one single angle. I want the sum of all the interior angles in there. So for the sum, that's our n minus 2. It's n minus 2 times 180. So I would have 42 minus 2, which would be 40, times 180. Okay, so we're going to multiply out 40 times 180, and I get 7,200. Okay, and for the next one, it's the sum of the exterior angles. So if you remember, the sum of the exterior angles, it's always the same thing. It's always 360. So if they ask you an easy one like that, sum of the exterior angles, it's always 360. Okay. Number 4, we want to have a little bit of knowledge of what specific type of parallelogram we're looking at. I can see right away that all 4 sides are equal. Okay. So if all 4 sides are equal, and it doesn't show me anywhere that there's 90-degree angles in it, so it's not a rectangle, it's not a square, but if all 4 sides are equal, I know that I have a rhombus. And a rhombus has some pretty unique properties about it. Okay, first of all, the diagonals will bisect each other like any parallelogram, but even better, we have the diagonals bisecting the angles that they live in. Okay, so this angle here and this angle are bisected and they're equal to each other. And then also within a rhombus, we have perpendicular diagonals. Okay, so what happens in here, if the diagonals are bisecting each other, we know that this is going to be 60, then this will also be 60. Zoom in way in here. And this would also be 60. So if I have a right triangle, and I know one angle is 60, then the other angle has to be 30. So I know right away 2x must equal 30. So I'll get x equals 15 when I solve that. And then I also know that 4y must also equal 30, right? This is 4y. If those are both right next to each other. So 4y also equals 30. And I think we get a decimal if we solve that. 7.5, right? Okay, so number 5 is a little tougher because they don't give me a picture. So I'm going to have to kind of make my own picture. I'm going to draw a parallelogram ABCD. Okay, so when I draw a parallelogram ABCD, okay, so that's about as good as I'll be able to draw a parallelogram ABCD with the stylus that I have. So you always have to go in order. So we go A to B to C to D. So the diagonals are AC and DB, and they tell me that they intersect at E. So I wrote the letter E in the middle here. So if AE is 4x minus 8, that's part of the diagonal here, right? That's this piece here, 4x minus 8. And then the other part, EC, is 36. Well, the diagonals in any parallelogram bisect each other. So we would just have 4x minus 8 this likes to zoom, equals 36. So we add 8 to both sides. And I have 4x equals 44. Alright, so x would equal 11. 4x equals 44, not. Okay, number 6, we want to find angle 1. Remember, in a parallelogram, opposite sides are parallel. So BC, he's parallel to AD. So I have parallel lines, and I cut them with a transversal here. This AC is basically a transversal. So angle 1 has to be equal to 38 degrees. Okay, this is a review from our parallel lines in the previous chapter, but the property there, those are called alternate interior angles, right? Angle 1 and the 38, they're alternate interiors, so that's why they're equal. So measure of angle 1 is just 38 degrees. It's right there in front of us. Okay, so when you submit your answers for number 7 online, I think I reversed the alphabetical order to maybe give you a hint and help you out so that you know you're going to have to find y first. There's no way to figure out what x is because there's nothing to pair it with. But in a parallelogram here, A and C are equal to each other. So I can start with y plus 10 is equal to 2y minus 40. So if I add 40 to both sides, and I subtract y from both sides, what do I get? I get 50 equals y right away. Okay, so I get y equals 50. Now, if I know that y equals 50, watch what I do next. Okay, if y is 50, this is y plus 10, right? So angle A is 60. Well, if angle A is 60, angle C is 60. And if this is a parallelogram, consecutive sides are supplementary, so these guys have to be 120 each, right? So I have a parallelogram that looks like this, 60s living across from each other, and then 120s living across from each other. So now we can easily get our x, because 4x is equal to 120. Divide by 4. And x is 30. Excessive zoom. Okay, so good luck everybody. Hope you have a great day.